In section 9.2, we're going to learn how to run our first significance test or hypothesis test. It's called a one sample z-test for proportions, or for a proportion, or for p. First, let's review the conditions and assumptions for the sampling distribution for sample proportions. We talked about this pretty extensively last chapter. So first of all, you have to have a random sample. Data needs to come from a well-designed random sample or a randomized experiment. We'll talk about experiments a little bit more in chapter 10, so I won't worry about that too much now. The 10% condition, when you sample without replacement, you need to make sure that your sample size is less than 10% of the population size. And then large counts, both n p naught and n q naught are at least 10. So our null hypothesis is going to be p equals some proportion, let's say 70%. And our alternate's going to be maybe greater than, right? And then we're going to get a sample proportion of maybe, who knows, right? I'm just making something up here, 77%, okay? So when we did confidence intervals, we checked n p hat greater than or equal to 10. And the reason we did that was because we didn't know the true p-value, not p-value, but the true proportion. And this was all we had. However, when we run a hypothesis test, we're always running the hypothesis test under the assumption that the null hypothesis is true. So if we assume the null hypothesis is true, then we should assume that p is equal to 0.7. So instead of putting in p hat here, we're going to put in p naught. This is called p naught. So our null hypothesis is that p is equal to some hypothesized proportion. So that's what we call p naught. So when we run a check on this, we should check np naught and nq naught. So it's kind of a detailed thing you need to make sure you're careful about. When we run a significance test, we collect a sample and assess the strength of the evidence that sample provides us against the null hypothesis. To standardize this procedure, we calculate the test statistic and the p-value. Now we've talked a lot about this process and calculating p-values from simulations and all this different stuff. But now what we're going to do is we're going to standardize that procedure so that it makes it easier to run and just more procedural. What's really going to happen is you're basically just going to kind of remember some steps, and sometimes I think if you don't maybe have to understand it as much to actually do it because you do the steps, but hopefully you understand it as well. So the test statistic is a measure of how far a sample statistic diverges from what we would expect if the null hypothesis were true. So the test statistic is simply a z-score. If you remember z-scores, you take your x minus your mean over your standard deviation. Well, if we calculate the z-score of our test statistic, which is a p-hat, right? We wanted to calculate the test statistic of our sample proportion. We would take our value, that's our x, minus the mean of the sampling distribution of sample proportions. Well, the mean is the true population parameter. Well, in this case, we're hypothesizing that it's 70%, right? So that's going to be our hypothesized value because we're assuming it's true, divided by the standard deviation of the sampling distribution of p hat, right? So that's going to be the square root of p naught q naught over n. And again, we put in our p naught and q naught here because this test is run under the assumption that the null hypothesis is true. So this is just a z-score, but it's using the values from our sampling distribution and our sample statistic. In general, it's always going to look like this. This is what's going to be given to you on the formula sheet. We need to construct it by putting in the proper values. Our statistic is p hat, the hypothesized parameter is p naught, and the standard deviation of the statistic is that guy. Okay? So this is how we calculate the test statistic. Once we have the test statistic, we calculate the p-value by simply finding the area associated with the test statistic according to the alternate hypothesis. So if the alternate hypothesis is that your p is less than the hypothesized value, we calculate the test statistic by looking at the area to the left of our test statistic. If it's greater than, then we're going to be here, and we're going to find the area greater than that test statistic. And if it's not equal to, we're going to find the area of one tail from our test statistic, and then we're going to double it. And in class, I kind of asked if you guys want me to explain that a little bit more, and you guys, kids kind of said, no, we'll trust you. There is a reason why we're looking at these things here, but I don't know. If you want to come in and talk to me about it, please come and talk to me about it. I don't want to take 5 or 10 minutes to describe it. So that's how we do it, though, okay? And this is how we calculate our test statistic, once again. And the name of our test is a one-sample z-test for proportions. Okay. So now we need to run through the entire procedure and do all of it. We laid the groundwork in section 9.1. Now let's actually get into the mechanics. To help us remember all the steps, I personally kind of like to use this technique that is, we do phantoms. It's a mnemonic to help us remember all the different steps. It's not perfect. The letters don't match up perfect, but I like it, so I'm going to do it. P, define the parameter of interest. H, set up your hypotheses, null and alternate. A, check the assumptions and conditions. N, name the test. Now on the AP test, we're going to name it, or we're going to put down the formula for the test statistic. On the AP test, you do one or the other. However, on my test, you have to do both. So for under the name of the test, or I don't know, maybe you want to put the formula down for the calculate the test statistic, whatever, but you need to have the name and the formula. Test statistic, what is the z value? 2.81, whatever it is, right? So formula on step N, calculated on step T. O, obtain a p-value. So O isn't really the right letter here, but obtain, calculate that p-value. Use your test statistic to find the p-value. M, make your statistical decision. And then S, state your conclusion and context. This is like the statistic decision. This is what non-statisticians are going to be able to understand. So phantoms. This is just an example for you to kind of look at to demonstrate it. I didn't really go over this much in class. You can kind of look through it, but again, let's just go through it quickly. P, what's the parameter of interest? Identify it using a symbol, using proper verbiage, and using context. It's got to have all three parts. Null and alternate. Typo, this should be an A. Null and alternate. Assumptions, 1, 2, 3. Don't just say random check, 10% condition check. I won't accept it. Just give me a nice, and it doesn't have to be a full sentence like this, but give me a statement that shows me you know what to do here for this. Check the conditions. And I do, this is another thing that they don't require in the AP, but I do require. We check large counts. It passes. We say, therefore, the sampling distribution of p hat is approximately normal. I do want that statement. Name or formula, but again, for my test, name and formula, 2 points. And then here you just got to give me the test statistic. Now, if you give me the formula and symbols, you don't have to put in all the numbers. I will show you eventually here how to type everything into the calculator to make it really easy, but right now, for the points, I mean, formula and symbols, or you can give me the formula with numbers, whichever one you think is easier. Symbols, it's easy to, by the way, it's supposed to be a p hat. Symbols, it's easy to forget details. Whatever. T, give me the number, z equals 1.33. P-value, calculate it. For the, excuse me, for the make the conclusion, compare your p-value explicitly to the alpha value, and your decision's either going to be reject the null or fail to reject, and then your conclusion. And remember, your conclusion is either there is or there is not evidence that the true proportion of whatever, that's going to come from right here, is, and then you always word this in terms of the alternate. is greater than 1/12. All right. Like I said, let's do an example here. Well, we're at the 10-minute mark. Next video, let's do the example.